Okay, now in the question 3, we want to evaluate the value of definite integral. Here, we want to evaluate integral of from 0 to 3 of this guy. So we find the antiderivative of each of them, right? Because they are the sum and the difference. So what is the antiderivative of x squared?
X cubed divided by 3.
Again, please.
X cubed over 3.
I'm sorry, the speaker is not very clear, but in order to do that, let me just explain. It will be x to the 2, and then the power of this we add with number 1 with, right? Multiply with a fraction whose denominator is exactly the power here, which is 2 plus 1. We do so, then we take the derivative. These two numbers will cancel each other, okay? That is the reason. The similar things. Now, what is the antiderivative of 1?
Would it just be 1x?
Yeah, just 1x. Very good. What is antiderivative of e to the x?
It would just be ex.
Very good. So e to the x. So you can double check the table on the notes I gave you before. This is the definite integral. Therefore, we need to evaluate the value at x is equal to the lower limit up to x is equal to upper limit here, right? 3. So, which will be valuation of 1/3 x cubed plus x minus e to the x when x is equal to 0 and x is equal to 3. So now we evaluate the upper limit. And what do we have here, Gary?
It would be 1/3 x times 3 cubed plus 3 plus e to the third.
Minus e to the third.
Yes, I'm sorry, minus.
We get the upper limit evaluation, subtract the lower limit evaluation, right? It will be 1/3 0 cubed plus 0 minus e to the 0. Okay?
Yes.
So it will be 3 square, not 3 cubed divided by 3. It will be 3 square. This is 3. Do you know how do we get 3 square here?
No.
Okay. Now let me remind you. It's fine. This is a product. 1/3. You can imagine it will be. We bring the number in the denominator up to the numerator. So this is 3 to the 1. Then we bring it up. We need to change the sign of the power here, right? This is 3 to the 1. And here is 3 to the 3, okay?
Mm-hmm.
And the power rule tells us that 3.
We'll just add those together.
Very good. That is why we have 3 to the power 3 minus 1, which is 3 to the 3. 3 to the 2.
Mm-hmm.
Yeah, that's it. Very good. And here the number 3 minus e to the 3e is a constant. Here 0 to the 3 give us 0. Multiply with any number will be still 0. 0. And here e to the 0, what is it?
1.
1. And so minus 1 give us
Plus 1.
plus 1. Good job. So we sum them up. This is 9 plus 3 will be 12, plus 1 it will be 13 minus e cubed, right? That's it. So definite integral gives us a number here. Okay.
Mhm.
Do you have any questions?
No, sir.
Very good. So now let us continue with the question B here. Now look at this. This is a quotient, right? Looks complicated. Can we make it simpler?
We can use I'm sorry. Can't you just subtract it from like the numerator and the denominator?
Very good. So this is a fraction, so we can separate it into 5x cubed divided by the denominator plus the second terms divided by x to the fourth here, right?
Mm-hmm.
Then x to the 5 divided by x to the fourth, the same story, power rule. What do we have here? X to the 5 minus 4, right?
So it'll just be 5x.
Yeah, the power rule. You see, they have the same base. So we just sum the power up. The power 4 here is in the denominator, so it should be negative 4. Okay?
Mm-hmm.
And here the same story. We will have 2 times, what is it?
6 minus 4.
Yes,
Oh, x minus
x
6.
squared, right? That is one way to think about it. Or you can think about it this way. Integral from 1 to 2, x to the 5, we can write it x to the 4th times x to the 4th, right? Because the power rule tells us that if the product of two numbers with the same base, x to the 4th times x, it would be x to the 5 here, right?
Mm-hmm.
X to the 4th times x squared gives us x to the 6th, the same things. But now if we write it this way, then we think that, okay, this one cancel with this one. This one cancel with this one, right?
Mm-hmm.
So it gives us 5 times x, okay? 5 times x here plus 2x squared dx integral from 1 to 2. So our job is to find the antiderivative of this guy, okay? So what is antiderivative of 5x?
It would be 5/2 times x squared.
Very good. X squared, and what should we do next?
It would just be 1/2, yeah.
Yeah, very good. And here it will be 2 x2, we add 1, it will be x cubed, right?
Mm-hmm.
Then we need to multiply by 1 over 3. And we evaluate it from 1 to 2, okay? Or let us write it clearly. It is from x is equal to 1 to x is equal to 2, okay?
Mm-hmm.
Then what do we have here?
Then it would be 5 times 1/2.
Yes, 5 times 1 half gives us 5 over 2, right?
Mm-hmm.
Then here,
And it will be 2 squared
very good. And
plus 2 over 3 times 2 to the cube, 2 cubed.
perfect. Subtract the evaluation of the lower bound, right?
Mm-hmm.
And it will be
5 slab over 2 times 1 squared plus 2 over 3 times 1 cubed.
very good. So then you can compute this guy, right? Yourself. Yeah, just you can use a calculator to simplify it. Okay? Or just do it together here. 5 and 2 squared divided by 2 gives us 2, right?
Yes.
Times 2 gives us 10. And here it will be 2 cubed gives us 8. 8 times 2 gives us 16 over 3. Here, this guy is subtract 5 over 2. And here it will be 2 over 3, right?
Yes.
But in front of that, there's a negative sign. So it will be
Negative 2 over 3.
very good. So these are fractions, and this is a whole number. We need to find the common denominator, right?
Mm-hmm.
What is the common denominator of this guy?
So you would multiply 5 over 2 with 06.
Very good. Here, we multiply by 3 and divide by 3 does not change anything, right?
Mm-hmm.
Then story here, if you multiply by 2 and divide it by 2, it will be same. But we have now, they all have the same denominator. 6 times 10 gives us 60 over 6. And here it will be 32 over 6 minus 15 over 6 minus 4 over 6, right? Yeah, then it would be 32 minus 15, it gives us 17 minus, this is 13, 13 plus 60, it will be 73 over 6. Okay, you can double check it yourself. These are numbers, so we'll not spend time on this too much. So is it clear?
Yes.
Very good. Now let us do the question C here, right? It looks complicated. To avoid confusion, let me cross it here. This is this, okay? Cross this here. Now we do this one. Okay. It looks complicated. Okay. What should we do now?
We should Can't you expand the
We're trying to make it simpler, right?
mhm.
We don't know how to evaluate, so let us write it this way. The constant, we can take it out of the integral. It will be integral from 0 to 1 over 1 divided by 2x plus 1 to the 4, right?
Mhm.
But we don't have any formula to evaluate this guy. It's really hard. What we know is the integral of x to the n something. So now if we replace it by a number, let us define, let u to be 2x plus 1, okay? So let us try. If u is 2x plus 1, what is du over dx?
So
Very good. 2x plus 1 derivative give us 2, right? Du over dx is equal to 2. It means that du will be 2 times dx, right? And remember, if we want to do a substitution, we need to replace du by dx by du, and we have the dx here. So therefore, if we divide both sides by 2, we know that du over 2 gives us dx here. Okay? So then this term, we can somehow write it in terms of du. But this is a definite integral. This integral depends on x. So, and it runs from x is equal to 0 to 1. When we change to the variable u, we should also change the limits here, right? The bounds. At x is equal to 0, from this relation we just defined here, we have to find the value of u, which is u equal to 2 times x is equal to 0, right? Plus 1, which give us
Mm.
1. 2 times 0 plus 1 is 1. Very good. So now the upper limit at x is equal to 1, we need to do the same thing. U will be 2 times 1 plus 1, which give us
3.
3. Yes, very good. Now, okay, let us rewrite our integral. Integral from 0 to 1 of 3 over 2x plus 1 to the 4th here, dx. We want to write everything in terms of u. You cannot mix between x and u. So let us write everything in the same terms. Before doing that, I think it's easier to write it as 3 times 1 over 2x plus 1 to the 4th dx, right? Okay, the constant 3, here we just rewrite it. Now, we change the limit. When x is equal to 0, then u will be 1. So the lower limit in the u variable will be 1 here. Okay? And the upper limit, it was 1. But now when we change to the variable u, it becomes 3 here, right? So the upper limit becomes 3. And now let us change the dx. Dx will be, is it? We replace du by this term, and we have,
It would be du divided by 2.
yeah, du divided by 2. Very good. The number is rewritten. Number 1 here, right? So, and what is the denominator?
It would just be the 4, correct?
Yeah, u to the 4. Very good. Now it becomes easy, right? This is a constant 1/2, so we can take it out of the integral to make our computation easier. 3 times 1/2 gives us 3/2, right? Integral from u is equal to 1 to 3, and 1 divided by u to the 4th. Can we write it in terms of u to the something?
-4.
Very good. -4. Perfect. Now, the antiderivative of this is du. Antiderivative of this guy, it will be u to the power here, but then we need to add 1, right? Then we multiply with a fraction whose denominator is this power. Okay? And we evaluate, now we're doing with a variable u, so it will be u running from 1 to u is equal to 3, right? Is it clear up to this step? Gary, Dylan?
So du is just a constant, so it's not anything.
Now, u is, before that, the variable was x, right? But now the integral becomes an integral of the variable u, because we change the variable.
Okay.
Yeah. But it's play the same role as an x to the 4th dx, right?
Mm-hmm.
Yeah. It is the same as 3/2, 1/3 of x to the -4 dx. But I don't want to confuse you more. Just leave it this way. Okay?
Mhm.
Then here, these are the constant. 3/2 times, this is -3, right? This is u to the -3. When u is equal to 1 to u is equal to 3. So the same things, we need to evaluate the upper limit, subtract the lower value, right? Before doing this, let us simplify this number. 3 cancel with -3, give us -1, right? This fraction becomes -1/2 of u to the -3. Is it okay?
Yes.
Very good. Then can you help me with this, Gary?
Sure. So it would just be -1/2 times times 3 to the -3rd minus 1/2. Well, it would be plus 1/2.
Yeah, now let us write it this way. Minus 1/2, right?
Mm-hmm. Times 1 times -3. Yes.
Then The negative here give us negative 1/2. This is a negative power, so we can write it, push it down to the denominator, right? It was negative 3, and we bring it down to the denominator. It becomes 3 to the 3. And subtract a negative number, it would be the same as adding a number, 1/2. This is 1, right? 1 to the negative 3 is still 1. Okay?
Yes.
Very good. Now, these are two fractions. Okay? They don't have the same denominator. So we can find the common denominator. So we see that there's a number 2 here. In order to have the same denominator, we need to multiply by 3 cubed and divide it by 3 cubed, right?
Mhm.
It is simply number 1. Then they have the same denominator, which is 2 times 3 cubed. 3 cubed is 27. Times 2 give us 54, right? And here is negative 1 times 1 and plus 3 cubed, which give us 26 over 54. They are all even numbers, so we can divide it by 2, give us 13 over 27. That's it. So are we good?
Yes, sir.
Very good. Oh, Ashley, can you join the Zoom meeting so that you can watch? Oh, interesting. Excuse me. Now we need to find the antiderivative of natural log x over dx. This is a quotient and it's really hard to find the antiderivative of this guy. So it means that we need to find a way to simplify our problems, right? Make it easier. Before doing that, let us write the constant out. It becomes natural log of x over x dx, okay? If we write it again, it will be natural log of x times dx and 1 over x. Okay, this is another way to write our integral. So now we need to brainstorm it, and we see that the derivative of natural log of x give us this guy, right? So if we defined u as natural log of x, so what is the derivative of u with respect to x? Do you remember the formula of derivative of this guy?
Be 1 over x.
Right. If we take derivative both sides, then what is derivative of natural log of x? Very good. it is u prime over u, and u in this case is x prime, right? X prime over x, and x prime is 1. So it means that du over dx is 1 over x, okay? So, or we write it, du will be, we multiply both sides with dx, give us 1 over x dx here, okay? And these terms appear in the integral here. This is an indefinite integral, so we don't have to change the upper limit and lower limit. What we can do is to substitute do you have any want me ask me something? Was you asking me, Dylan? So now if we replace the function ln of x by u here, what do we have here?
We'll get u times du.
Yes, u times du. Very good. Okay. Now integral of u du, it becomes easy, right?
Mm-hmm.
Now the variable is u, therefore it will be u to the,
Squared,
yes, u squared.
1/2.
Very good. Okay. What do we need more? This is an indefinite integral, so we need to, yes, plus c, where c is a number. Okay. Very good. Then, but the question is to evaluate this integral in terms of x. What we found was in terms of u, the new variable we just defined. So we need to replace it by the original variable, right? So we need to replace u by ln x here, okay? So what do we have?
It would be 1/10 times ln x divided by 5x squared.
No, u is ln
I'm
x.
sorry, ln x, yeah.
Yes, very good. That's it, right? We're done. Okay. Is it clear now?
Yes.
Mm-hmm. Very good. Let us continue. The next one, the next one below this, right? E. Oh yeah, we're doing the question F here. We're doing the question F here. Wow, it looks complicated. So now let us try. See, x plus 4 to the 9. It will be x plus 4 times x plus 4 times x plus 4, 9 times, right?
Mm-hmm.
If you want to FOIL it, if you want to do so, it will be x to the 9 plus something. too many things in terms here, right? And in front of that, there is a number x here. There's a variable x in front of that here. It means when you multiply with x, then it becomes a very complicated term. It's not easy. It takes a lot of time, right?
Mhm.
So let us try to change a variable, and hopefully it would make our life easier. Now, I'm looking for your suggestion. If we let u to be a function of x, what do you think? Which we should replacement? Perfect. Yeah. Now, you see, if we replace the difficult terms here, if we replace u by x plus 4, then we see that x plus 4 to the 9 will be simply a variable u to the 9, right? They're the same thing, okay? Somehow it becomes an easier one. But before doing this, we need to find the change in u and in x, right? What is du over dx? We take derivative both sides, right? Okay, du over dx, or it is u prime. U prime will be x plus 4 prime, which give us what is it? 1. Very good. Du over dx is 1. Therefore, du will be equal to dx, right? So is it clear, Dylan and Gary?
Yeah.
Yes, very good. Then, okay, what should we do next? Here, there's a terms in x, right? We know that u is x plus 4. Therefore, we need to write everything in terms of u. It means that we need to replace x by, how can we find x here? From this equation.
It would just be u divided by 4 equals x.
Subtract.
Oh, I'm sorry, plus 4. Plus 4.
Minus 4. We subtract 4 in both sides, right?
Yes.
Then okay, very good. We have everything. So we want to compute integral of x plus 4 to the 9 dx. Now we can write everything in terms of u. Okay, we know that x is u minus 4. Okay, and here x plus 4 to the 9 becomes, yes, u to the 9. And dx is equal to du. Okay, now it becomes a simpler integral. What should we do now?
Take the antiderivative.
This is a parenthesis, right? Let us distribute it and see. It will be integral of u times u to the 9. It will be very good. And here, no, very good. 4 times u to the 9. And then we take, multiply with du. Okay. This is the, we need to find the antiderivative of this guy. it will be what is the antiderivative of u to the 10 here?
It's like what we just did, but in the opposite direction. So it would just be u minus 4 times e to the 9? Or would
No, look at this. Okay, let us separate this first. It will be integral of u to the 10 dx minus integral of 4u to the 9 dx, du, sorry, this is du. So integral of a difference will be the difference of integral. That is the properties. And now the number 4 here, we can take it out of the integral sign, right? Okay, this is simply a variable u to the 9 du. Antiderivative of this, it will be u to the 10, but now we add 1, right? Remember, we need to divide by the same amount, 10 plus 1 here. Okay, because when we take derivative, we need to subtract 1. And the next terms, it will be negative 4 times u to the 9 plus 1. Same things, 1 over 9 plus 1. Okay? And this is an indefinite integral. Therefore, we need to add a number where c is in R. Okay? Let us simplify it. 1 over 11 u to the 11, right? Minus 4 over 10 u to the 10 plus c, where c is a number. Wait a minute a second. So, are we done?
Oh, my mom is here to me. Do you have office hours tomorrow too?
So now we're looking for the antiderivative of all these things, right? We need to replace to the variable x.
You want me to take one?
All of them, all of them.
Oh, all of them?
Yes, for you.
Thank you.
You're welcome. Let me do one more second. Okay. That's it. Is it clear?
Yes, sir.
Very good. So we can continue with the next question, right? Can we continue, Dylan?
Yes, sir.
Okay, let's do it. Okay, this guy. It looks scary, but it's not that scary. Here, oops. Yeah, integral of x of 6 root of x to the 7 we can write it according to the power rule. It will be x to the what?
7/6.
7/6. Perfect. That's it. This is a number. We know that antiderivative of this guy, it would be 7/6, and what should we do?
+1.
Perfect. Then we multiply with a fraction whose number denominator will be exactly the same power here, which is 7/6 plus 1. Okay? What else do we need?
Plus a constant.
Perfect. Okay. Then our job is to simplify it. That's it. So here, 7/6 plus 1, if we multiply it by 6 and divide it by 6 here, right? Then they have the same denominator. It will be 1 divided by 13/6, okay? Then 1 divided by a fraction, it will be the reciprocal of this, it will be 6/13. And x to the 13/6, it is the 6th root of x to the 13 plus c. Okay. Is it clear?
Yes.
Perfect.
Would it be, could we still leave the, can we still leave it as 6/13 times x to the power of 13 divided by 6?
Yeah, it's okay. I'm fine with that. But yeah, in the future, I think it's nicer if you write it this way, but it's okay.
Okay.
Yeah. As long as you understand and can find the answer, we're good. And the next one will be this one. Okay. I think it's not difficult. We can do it directly here. Antiderivative of each of them here, right? The number, we just rewrite it here. X squared, antiderivative of x squared will be x squared at, what is it? What is it here?
1/3.
Perfect. 1/3. And the same story here. It is x to the -2. Then we need to add 1. What should we do here? Divided by this power, which is 1 minus 2, it is -1, right? And we need, this is an indefinite integral. We need to add a constant where c is a constant here. This is 2/3 x cubed. This multiplied 1 is 3, divided by -1 give us -3. X to the -1 plus c, right? And in the test, I'm okay with writing x to the -1, or you can write it as 1/x. They're the same. That's it. Okay. Is it clear?
Yes, sir.
Perfect. You're doing great, Gary. I see that You try so hard. Good job.
Thank you.
And now let us continue with question E. Okay. It looks complicated. What should we do?
We should can't we take everything and put it like we'll have it at a certain I don't know how to explain it, but I know how to I know what I'm trying to say. We'll have it like x, it'll be like x to the negative 1/2 plus
Here,
I
look
don't
at
know.
this. Sum of the fraction with the same denominator, we will add the numerator together. And now we can
Mhm.
separate this fraction in terms of 9 over x. And the second term will be
1/2.
Square root of x.
Negative 1/2.
Yeah, very good, very good. That is good. But let us do it slowly. But I see what you mean. Okay? When we break it into small pieces here, it becomes easier. 9 over x, or we can write it 9 times x to the negative 1, okay? Or let us just leave it this way, 1 over x. And here, square root of x is x to the 1/2, right? And x in the denominator, oh, this is plus. We write it, bring it up, it would be x to the negative 1. Do you agree? And here, x divided by x gives us
1.
yeah. Let us simplify it first. Now, x to the 1/2 times x to the negative 1 give us so they have the same base. So we add the power together.
Negative 1/2.
Very good. So now it's easy. We need to find the antiderivative of 1/2, 1 over x here, right?
Mhm.
And what is it? You can look up at the table.
Wouldn't it be ln x?
Perfect. Remember ln of absolute value of x.
Oh,
Be-
yes.
Yeah.
Mhm.
And here, the same story, x to the negative 1/2 at 1, right? Divided by this number. And antiderivative of 1 will be x. And we add with a constant. Add a constant here. Okay. Now our job is to simplify it. It is 9 ln absolute value of x. 1 divided by negative 1/2 give us what?
Wouldn't it be 2?
Negative 2.
Negative 2? Okay.
There's a negative sign in the denominator, right? So be careful. Oh, negative 2. Sorry. Here is x to the negative 1/2. Oh, x to the 1/2. Very good. Plus x here, right? And plus c. where c is a constant. So it is 9 ln x minus 2 square root of x plus x. That's it. Plus c, right?
I'm sorry, but why is it -2 instead of just 2? Because I thought we'll use -1/2 plus 1, which is 1/2 over 1. So that would just been 2.
Oh, you're right. You're right. My mistake. Yeah, you're right. And this is positive. My bad. Thank you. Yeah. We learn from mistake. It happens to everyone. Okay. Very good. Is it clear, Dylan? So can we continue? Oh yeah, we've done each already. And now we've done I. Now we do J, right? This one. Do you have any suggestion for this one? This is integral of a sum, so, and the constant, we can take it out of the integral. It becomes integral of x squared dx plus integral of 8, or let us write 8 times integral of 1 dx plus 2 times integral of 1 over x squared plus 1 dx. We separate this into small integrals, okay? Each of them becomes easier. So the first guy, what is the antiderivative of x squared?
It'll be 1/3 times x to the third.
And here, antiderivative of 1.
It'll just be x.
Very good. 8 times x. And here, the number 2. Look up this formula in the antiderivative sheet I gave you in the class. What is it? You see the section 5.4 notes?
It is it's negative, well, tan, it's the inverse of tan.
Perfect. Tan inverse of the variable x. And finally, we need to add with a constant, right? C is a constant, or C is in R. That's it. Okay? That is the question J. Let us continue with, okay. Is it clear with the question J?
Yes.
Perfect. Now, wow, this guy, 7 times 1 plus tangent square. Do you see any formula of this antiderivative? If not, what is your suggestion to solve it?
We can try to simplify it a little more to see if we can find the derivative.
Sounds good, but how can we do it? Very good.
Because tan squared is
Sine square over cosine square, right?
yes.
Good job. So it is sine square x over cosine square x. Again, this is a whole number. This is a fraction. Okay. Then what can we do to add them up?
We can do the we can separate them, like separate the integrals, maybe. Oh, or we can.
If we separate it, is really hard because we don't have a formula of antiderivative of tangent square, right? It's hard. But if we do it this way, cosine square, then they have the same denominator, right? So we can add them up. It would be cosine square plus sine square, right? Okay. Can we simplify it further?
Wouldn't it just be sine squared x?
So cosine square plus sine square gives us 1, right? So it becomes 1 over cosine square. The trig identity tells us that cosine square plus sine square is equal to 1. But again, this 1 over cosine square is 1 over cosine. 1 is 1 square. So this, if they have the same power, the power rule tells us that, okay, it will be the fraction here, and they both raise to the same powers. 2 dx. And 1 over cosine is simply secant, right? Secant squared dx. Do you see it?
Yes.
Very good. Now, because we don't remember the formula, but now after some computation in the future, if you see this guy, 1 plus tangent square, you can write it down immediately here, equals secant square. Memorize it. Will save a lot of time, okay?
Yes.
So then you can write directly here to here, 7 secant square. Now look up the table. What do we have?
For the derivative of secant squared.
Antiderivative of secant square. Very good.
Wouldn't it be 10?
Perfect. 10x. And what do we need to add here?
A constant.
Perfect. Remember. Yeah, very good. Okay. Good job. So, is it clear, Dylan?
Yes, sir.
Great. Okay, I think we are done with these problems. We have solved all